Everybody ready? Here is the very first algebra question that is super duper easy. P plus 2 equals 5. Oh, I haven't turned it on. What an idiot. The answer is B equals 3. Everybody got it. Now, why? Karen. Excellent. Excellent. I am very happy that the person I called on did not say, because 3 plus 2 is 5. Because that is the wrong answer. Do you all understand that? Yes. The reason that is the wrong answer is because if I change this question to P plus 1.174 equals 8.263, you can no longer say because 2 plus 3 is 5. Right? To solve the red question, you must actually use algebraic principles. Right? And those algebraic principles are what Karen just said. That's all you need to know to do algebra. Anything you do to one side, you have to do to the other side. That's it. So what Karen did was she subtracted 2 because she had to move that 2. She needed P isolated. She moved the 2. Why did she have to work on both sides? Because equals means both sides are the same. You all already know that. And yet, when I gave you that question in the review, a bunch of people are like, what?
That same question right there?
Essentially. Is that not the exact same mathematical principles as that? It's exactly the same. Yes, except when I gave this to people, people left it blank and told me they couldn't do it. When they can do that. Because what would you do there? No. Minus 1.174 from both sides. And the answer would be 9, 15 minus 7 is 8, 1 minus 1 is 0, 8 minus 1 is 7. And that would be the answer. Because I subtracted. Now, where you people go wrong is you refuse to show that work in those easy questions. By not showing that work when it's easy, when it comes to a really complicated algebra question, you don't bother with the work, or you skip steps. All right, let's remind you of the other thing. What is P? And I'm going to stop using P. I'm going to change letters. What is J minus 5 equals negative 9? Jovan. J is negative 14. It's hard to do in your head, isn't it? What makes it easier? Writing it down. I have a negative 5. What do I do to get rid of it? Marcus. I add 5. If I add 5 to the left side, what happens to the right side? You add 5. Negative 9 plus 5 is negative 4. Right? Great. What do I do here? 3m equals 9. Divide by what? y3. You have to isolate the variable. And you don't want that 3 near the variable. And anything you have to move, you have to do the opposite of what you see. Because algebra is unpacking something. Divide by 3, divide by 3. So now I have m equals 3. What if I have this one? 4 over x equals 2.
Wait, yeah, 8.
Marcus. Multiply what? Multiply the 4 by 4? But I don't need to move the 4.
Times 2.
Okay, no, I hear what you're saying. So if I multiply this 4 by 4, what do I get? What's 4 times 4? 16 over x equals 8. Jovan. Multiply the x on both sides because your goal is to get x by itself. So in this case, and only this case, we should start with x. They cancel. 4 equals 2x. Divide both sides by 2. X equals 2. Yeah? That is all you need to know to do algebra. So what happens if I go to this spot? 3i plus 4 equals 10. No, I lie. 10 equals 3i plus 4. Oh my goodness, I made it look different. Are there different rules?
Oh. I is 2.
Excellent. Why?
Because 2 times 3.
Wrong.
Oh, okay, hold on. I got you. Because what you have to do towards it, you must do towards it. So,
Okay, now you're getting warmer.
that's what I
So
did.
what do you do?
Same thing. What do you mean?
Tell me
Just
what to
learn
do.
how to do.
Tell me what to
I
do.
don't know. I just did it.
The reason I am asking you this, Jovan, is because yes, Javon, it's wonderful that you can do that in your head. But if I change this to 37 equals 3.7i plus 8.2, can you do that in your head?
It'll take me a while.
Start. No pens. Do it in your head.
Yeah, it's gonna take me a while.
Mm-hmm.
Try.
Yeah.
I
Okay.
definitely could do it, right? But like,
Sure.
you know,
Okay. Now, on paper, what is it?
give me a moment.
You have all the moments you need. Everybody should be practicing this on paper.
All right. I got you.
Because a lot of stuff is going on here.
Oh my.
But is anything going on here? The exact same question, isn't it? Except I put the 37 on the other side. It looks different. Do we do any different math? No. I do minus 8.2 minus 8.2 to get 28.8 equals 3.7i. Then what? I divide by 3.7. And I equals whatever that is. Can you do that in your head? No. So you get out your calculator. But it's no different than if you were doing numbers that worked perfectly. Everybody good? Sweet. What if I give you this type of question? 3x plus 4 equals x plus 14. Marcus.
You'll minus the 4 to the side and minus the x to the 3x side and then divide the
Excellent.
4x.
So I would take away 4 from there and take away 4 from there. Then I would take away x from there and take away x from there, which would get me 3x plus 0 equals 0 plus, 2x plus 0 equals 0 plus 10. Then what would I do?
Divide it by 2.
Divide it by 2. X will equal 5. None of this is difficult, is it?
No.
Okay, what if I gave you this? 2x plus 5 divided by 3 equals 3. Amrit. Then what happens? 2x plus 5 equals minus 5, 2x equals 4, x equals 2. Right? How easy is this? When were you taught this? A long time ago, right? So, why then did anybody have trouble with surface area equals pi r squared plus pi r slant? And I told you that the surface area equaled 1,200 and the radius equaled 5. What made that any different from that? Thank you. Want to say that louder? It looks harder. It looks different. If I walked in here wearing a sheet over my head with 2 little holes cut in it and going, "Ooh, we are going to do math today," would there still be math happening? Would 2 plus 2 still equal 4? Even though I looked different, yes? Right. So do we care about the looks of something? No, because it doesn't matter what it looks like. The rules apply. Now, up until now, you have done algebra just with numbers and variables, yes? Okay, what makes this, which is going to be green once I put the yellow over it, what makes that seem more difficult? What part of that green line? Yes, Josh?
You have like the R and pi.
You've got pi, r, s. You have 3 things that are not numbers, don't you? And that scares you, doesn't it? But what is pi? It's just a number, isn't it? Why do we use that symbol? Because how big is that number? How big is that number? Would we ever stop writing the decimals? No. So could we even do math if we actually wrote this as the number that it is? No. Right? It would be impossible, wouldn't it? But if I asked you to tell me what 5r equaled 25, could you tell me r? Why? How do you do that? You divide by 5. You divide by 5. So what makes that different from that? Number times a variable. Number times a variable. Divide by pi. Divide by pi. Everybody with me? This concept is the complete basis of the next unit. You have to understand that math goes further than 0 through 9. Okay? And all the rules that apply to 0 through 9 apply to all these symbols as well. Is everybody cool with that? All right. What if I gave you... Actually, I think we might be okay. You guys picked that up much more quickly. It's because it's the afternoon. We might be good. All right. Let me ask you this. No, I have a better question. Let's see if you can actually do it. Well, let's do that question that we just had. The surface area equals, let's say, 175. And let's say the radius of this cone equals, let's say it's 7. find S. I'll even help you out and rewrite the formula. Remember, you don't ever need to get out your calculator. You can just show me what's happening. You didn't have to get out your calculator, Marcus. So, can we put some numbers in there? What goes where? 7 replaces R and 175 replaces SA. 175 equals pi times 7 squared plus pi times 7 times S. I want S by itself. If I was driving to Disneyland, would I start in Disneyland? No, I would have to start at home, correct? So if I want S by itself, should I start at S? No, I should start nice and far away from S. So let's start nice and far away from S. What's the furthest away from S I can get? 175 equals 7 squared pi. 7 squared is yucky. Can we fix it? What is it? No, we square it. No. Because we're not trying to find 7. We already know 7. We're trying to find the S. Only if it was an R or an unknown. Plus 7 pi
Do you know Mr. Kemp?
Do I know Mr. Kemp?
Yeah.
I know of Mr. Kemps. I don't know if I know the Mr. Kemp of whom you speak.
There's like 3 of you guys. There's Mr. Harvey, you, and Mr. Kemp. So you're like all the same.
Yeah, because you use like not like the whiteboard. Like you use like this type of stuff.
It's the 21st century.
I know, Mr. Borson uses the whiteboard.
Like Mr. Harvey and Mr. Kemp. More than
Yeah, that, I like that.
All right.
Whiteboard stuff, like that's my jam.
Okay.
Wow.
Sorry. 49 pi, 7 pi S. There we go. So now, here is what bothers you people.
Your board thing's not on.
If I told you that this right here, if I told you that was 150 plus 7 pi S, how would you get rid of that 150? You would subtract it, right? Okay, all of you know that, right? So what makes this difficult? Isn't that just subtract 49 pi?
Yeah, how do you subtract 49 pi?
Okay, pi is a number, right?
Yeah.
And 49 is multiplying that number, right?
Yeah.
So if I told you that this right here was 49 times 3, that's 147, yes?
Yeah.
And you would just subtract 147, wouldn't you?
Yeah.
So this is just 49 times a number. That number is pi. So I subtract 49 pi's. Now what bothers you is because it's not written out as a number.
Yeah.
But it is a number. right? So,
Why is
I'm-
pi called pi?
I don't know. It's a Greek letter.
You should look it up.
No, because I don't care.
But I do.
Then look it up. The entirety of the internet, the entirety of human knowledge is at your fingertips.
Is it really the entire?
Yes, the entirety.
Like stuff that. Is
Yes.
51.
The entirety. Minus 49 pi equals 7 pi s. Now, if this part was 7s, how would you get rid of the 7? By dividing by 7, correct? Why did you divide, Jacob? Because this is multiply by s. So when it's multiply, you divide to get rid of it. Well, isn't this just 7 times pi? So I divide by 7 pi. If I do something to the right side, I got to do the same thing to the left side. Now the 7 pi's cancel, and I know my s. It is that. Now, that is the right answer. Is that the answer you can take to Home Depot? No. But is that the answer that gets you through Math 10? Sure. If you can get to there, you actually can do math. Because when you find a number for this, which your calculator will find, and it'll be a big long decimal, is that math?
Yeah.
Or is that arithmetic?
I got your joke. Go.
What's doing the work over here? To get me a number that I could take to Home Depot. Who's doing that? The calculator. Before you can go to your calculator, who had to do math? You. All of you can do that. You cannot be fooled by looks. It is the number one thing math teachers face, and we hate it. We tell you x plus 3 equals 5, and you're like, I can do that in a second. Then I give you m plus 7 equals 12. Oh my God, I can't do that. I only know how to find x. And you laugh, but I have had students do that. In Pythagoras, a squared plus b squared equals c squared, right? I have given students triangles like this and called that side b. Isn't that the hypotenuse? So it should be the longest side, shouldn't it?
Yeah.
But I will call it b, tell the kids this is 3 and this is 4, and they will tell me this is shorter than 4 and hand it in to me. No, it's not that. It's because you're not looking at what's actually happening. Math is not difficult. If you write it out, everything's there for you. But you have to try it. You cannot leave it blank. Now, here's what we are going to do. It is 1:31. I am going to give you a package of algebra practice. And that algebra practice are puzzle sheets. Now listen to me. The first two are of this variety. 3y plus 7 equals 28. Questions like that. Okay? The third one is this. A number times 7 is added to 3. How do I make that algebra? Karen.
7x plus 3.
Perfect. Could I also write 3 plus 7x? Yes. What if I said this? What if I changed it to a number is added to 3 and then multiplied by 7? How would I write that one? So I've changed it the same. A plus 3 times 7. Nope. Okay, so I'm going to tell you that the number is 2. Before, we had a number is multiplied by 7 and then added to 3, right? So the number is 2. So what is 2 times 7? Plus 3? 17. Agreed? When x equals 2. Now the number is still 2. A number is added to 3. Right? So the first thing I do is add the number to 3. 2 plus 3 is what? 5. And then multiplied by 7. 35. Are they the same? No. So how can you make this blue one happen? Brackets. What is it? X plus 3. A number is added to 3. And then multiplied by 7. Everybody cool? I know it seems like a bit of a step backwards, but I feel it is necessary based on what happened with substituting into formulas. Okay? And it's not going to slow us down very much because it's only one block and half the class isn't here anyway, so it would have been a super pain in the ass to start a new thing today and have 20 people, well, we did yesterday. Did you watch the video? No. So, take this, do the puzzle sheets. Now listen, I know a great many of you, when you do these little puzzle sheets, when you get about halfway through, you start recognizing what the words are going to be and you start cheating. Right? Like if you saw this word, M blank blank Y blank R S I S A blank E S O blank blank.
Myers is awesome.
You would stop doing the math and write, Mr. Myers is awesome. But some of you would try to spell it as awful. But that's okay. It doesn't hurt my feelings. Why do I give you the puzzle sheets? Is it so you can crack the code? No. It's to practice the math. And the puzzle sheets are a lot less heavy than a textbook. And you get the payoff of the funny joke at the end. Because these are some class ones. Okay? Now listen to me. I know that most of you aren't going to do all of this. I'm well aware of that. I know that's going to happen. You have almost an hour you could work on it in class. If you are going to shirk and not do everything, I really recommend doing the second 2 pages. Because the back of the first page has some more difficult algebra on it. Maybe you want to practice a bit on the first. I don't know. It's up to you. You know where your algebra weaknesses are. You should know that a great many of you have some weaknesses in algebra, which is evidenced by the fact that a great many of you didn't do and left blank the algebra questions on the last assignment I gave you.
What?
What? Mr. Myers, what are you saying? We all did it.
All of us.
Every one of yous.
Yep.
Take one of these and work. Because like I say, with this many people missing, there's no point in doing something new.
Okay.
There's going to be a ton of extras because I stupidly photocopied 3 class sets worth when I only needed it for 2 classes. I don't know why I did that. I'll take the extras back here.
What's karate? What are you talking about? What is this first one? They both have a point. That's why. They both
class.
They both have a point.
Maybe.
Probably that.
Okay.
Let's check the work.
You do as much work as you need to do. If you can do it in your head, I don't care if you do it in your head. But you're not going to be able to do the second and third ones very well in your head. You do as much of them as you want, Lasse, because if I say do all of them, half the people aren't going to do all of them anyway. You do as much as you feel you want.
Why do I have two? Here, take this.
You got forgotten, you ting.
Wow. There's an extra. Here.
Sweet. Thanks, brother.
Yeah.
I'm going to do attendance, and then I will be available to you if you need me, but I don't think you will. Stop recording.